In this video, let's talk about section 7.7, graphs of the tangent, cotangent, cosecant, and the secant functions. So in the last section, we studied the graph of sine and cosine. Sine looks like this. Let's recall. The wave function. This is y equal to sine. One period is 2 pi. This is pi. And then cosine. So this is 2 pi. This is pi. Okay? It's also one period. It's pi over 2. 3 pi over 2. And 3 pi over 2 and pi over 2. And we know that the sine of x is equal to cosine of x minus pi over 2. You shift the graph to the right, pi over 2 unit, you will get the sine. You shift it. So see, if I draw the complete the other part, so you shift it to the right 2 unit, you will get it. Okay. This is the sine and the cosine. These two graphs are very, very close to each other. But let's talk about the other ones. For example, the graph of a tangent. If we just get certain sample point, for example, when we talk about negative pi over 3 and negative pi over 4, negative pi over 6, 0, and pi over 6, pi over 4, and pi over 3. This is for the input x. We know the tangent is an odd function. Tangent of negative x is equal to negative tangent of x. So for example, let's first just recall the values of a tangent is pi over 3. Tangent pi over 3 is square root of 3. Tangent pi over 4 is 1. Tangent pi over 6 is square root of 3 over 3. Tangent of 0 is 0. Tangent is the sine of a cosine. You just use sine, cosine, you take the ratio, you get it. And when you get the negative sign, negative angle, you see, you just add a negative value. So you get a negative root 3 over 3, negative 1, and a negative root 3. Right? So once you get those values, let's try to sketch the graph. And also we know that the tangent is undefined at pi over 2, pi over 2. Undefined. So tangent at negative pi over 2 is also undefined. Okay, so we have negative pi over 2 undefined, positive pi over 2 undefined. And the reason it is undefined is that tangent of x is sine over cosine. When you have pi over 2, cosine is 0, sine is 1. So it's 1 over 0, it's infinity. So tangent pi over 2 and the tangent negative pi over 2 are two vertical asymptotes. The two vertical asymptotes, okay? Okay, now we draw two walls. And let's check. Pi over 4 is 1. Pi over 4, 1 is here. Negative pi over 4 is negative 1. And other values, they are irrational value. We just try to 0, 0. We just try to estimate it. It's a negative 1.73. 1.73 is less than 2. So pi over 3, pi over 3, someplace here, okay, and here. So if you sketch it, if you have more values, you sketch it, you will have this. Okay, so this is a graph of a tangent of x. It will approach positive infinity when it approaches pi over 2 from left side, approaches negative infinity when it approaches negative pi over 2 from right side. Here it approaches negative infinity because, okay, so when you draw this, you will realize this is a x between 0 and pi over 2. So this is quadrant 1. This is in the first quadrant. And between negative pi over 2 and 0, this is in the quadrant 4. So in quadrant 4, sine is negative, cosine is positive, so the ratio is negative, so it approaches negative infinity. Okay, so let's see this. Pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, something like this. And here's negative pi over 2. And if we talk about the quadrants, this is quadrant 4, quadrant 1, quadrant 2, quadrant 3, quadrant 4, and then it back to quadrant 1 and quadrant 2, and something like this. And to the left, it's a quadrant 4, here, negative pi. This is a quadrant 3. Okay? So this is about the quadrants. And over each different quadrants, you know the sign. Tangent is negative over the fourth quadrant, so it approaches negative infinity. Okay, this is a graph between the negative pi over 2 and the positive pi over 2. We know tangent has fundamental period pi. So if we want to get a complete graph of the tangent function, it's like this. It's a pi, negative pi over 2, pi over 2. This is a pi. It's a 3 pi over 2, 2 pi, 5 pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. And then you draw the vertical asymptote, and here vertical asymptote, vertical asymptote, and vertical asymptote. Okay, and over each region, you get a one infinite curve. Over each region, get a one infinite curve. To the right, it approaches positive infinity. To the left, it approaches negative infinity. And all the curves are identical. Okay, so this is a graph, and you will write them for the infinite region. So you have infinitely many such graphs. and they have the vertical asymptote pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. Okay, so this is a complete graph y equal to tangent of x. Okay. Okay, from this graph, let's summarize the property. Properties of tangent function. First, the domain is the set of all real numbers except odd multiples of pi over 2. So you see here, pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, or negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. So that's why you only accept exclude the odd multiples. This is how you study it horizontally. If you study it vertically, the range is from negative infinity to positive infinity. So it covers the whole y-axis. Three. Tangent function is an odd function. Odd function, the graph is symmetric with respect to the origin. Okay, so you rotate it pi radian, you have the same graph. For the tangent function is periodic. With period pi. Okay. 5. X-intercept. X-intercept what are the x-intercept? 0, pi, 2 pi, 3 pi, 4 pi, or negative pi. So k pi. Or integers, positive, negative. K pi for all integers, k. Y-intercept. Zero. Only this point. It is a y-intercept. 6. The vertical asymptote. Vertical asymptotes. The graph of tangent function has infinitely many vertical asymptotes. Their x is, you see, it's always k pi plus pi over 2. K pi plus pi over 2 for all integer k. every time when you have an integer, you integer multiple of a pi, you plus pi over 2, you will get asymptote. You see, this one is negative pi plus pi over 2. This one is 0 plus pi over 2. This is a pi plus pi over 2. Okay, so it's always like this: k pi plus pi over 2. K pi plus pi over 2. Okay, so this is the list of the basic properties of tangent functions. Once we get the basic graph, and we can transform it. We can do the transformation. Example, graph y equal to 2 tangent x minus 1. Okay, so because it's a periodic function, I'm going to just graph one period. Okay, so first get negative pi over 2, positive pi over 2. And even though we know many values for the tangent, but most of the values are irrational. So the only rational value we know is a pi over 4. At pi over 4, it is equal to 1. For example, pi over 4 is equal to 1 here. Negative pi over 4 is negative 1. Okay, so you sketch it. So it's a graph y equal to tangent of x. Y equal to tangent of x. And then you're going to multiply the tangent of x by the coefficient 2. You're going to do the vertical stretch. Okay, so it's negative pi over 2, positive pi over 2. It's pi over 4. Originally it's a 1, it's here. Now it becomes 2. Multiply it by 2. Tangent of pi over 4 is 1 times 2 is 2, so it's here. 0 is still 0. Negative pi over 4 is negative 1. Now it becomes negative 2. So it's more steep, more steep, much more steep. Almost a straight line, but okay. This is a y equal to 2 tangent of x. So it's a vertical stretch. It's a vertical stretch. It's here. 1, 2, negative 1, negative 2. Here's a 1. Here's a 1. And then subtract 1. It means you're going to shift it vertically down 1 unit. So the 2, if you shift the 2 down, it becomes a 1. So this is first let's sketch 2 vertical asymptote. Negative pi over 2, positive pi over 2. And 0 is shifted to negative 1. And negative 1, negative 2, negative, this is a negative 1, negative 2. Negative 2 is shifted to negative 3. Okay, so it's a similar step, similar steps. Just get a different graph, and this graph is more steep when you have a coefficient 2. Okay, so this is a graph y equal to 2 tangent of x minus 1. Okay, let's try another example. So we have y equal to 3 tangent of 2x. 3 tangent of 2x. So you have the stretch and you have the compression. So I'm going to do the compression first and stretch second. First, we copy this graph. Negative pi over 2, positive pi over 2, pi over 4 is 1, negative pi over 4 is negative 1, y equal to tangent of x. And if you multiply x by 2, you are going to do the horizontal compression. So pi over 2 becomes pi over 4. This multiplication by 2 is a compression. Negative pi over 2 becomes negative pi over 4. And then this is pi over 4. You compress it, you will get pi over 8. Pi over 8 is 1. And negative pi over 8, the number will be very small. Will be negative 1. And you stretch it this way. Okay, so horizontal compression make this very, very thin. This is y equal to tangent of 2x. Now let's use this piece. And then we multiply this tangent 2x by 3. We multiply the tangent 2x by 3. We will have the following thing. It will be off scale. Still, you get a negative pi over 4 and a pi over 4. Very, very thin region. Originally at pi over 8 it's 1, but now it becomes 3. And so see, you just get the vertical stretch, you will get you can get the idea. So it's even more steep, very, very, very steep. So it's y equal to 3 tangent of 2x. Okay, so this is a graph. Right? So if you are required to sketch the graph of this periodic function, you just sketch one period. That's enough, because other piece of graphs will be identical to this one period. You just shift it to the different period. Okay, so this is y is equal to 3 tangent of 2x. Now let's see the cotangent. Cotangent is cosine over sine of x. When x is 0, cotangent is undefined. When x is pi, cotangent is also undefined, because sine 0 is 0, sine pi is 0. So we have zero part and pi part. And okay, and when you get pi over 2, cosine pi over 2 is 0. So it make cotangent pi over 2 is also 0. And remember, this is the first quadrant, this is the second quadrant. Between 0 and pi over 2 is the first quadrant, all the values are positive. Between pi over 2 and pi, it's the second quadrant, all the values negative. All the trig function values positive. In the second quadrant, only sine is positive. Sine, cosecant are positive. Cosine, tangent, cotangent, secant, they are all negative. And here is 0. Okay? So cotangent will be a negative. And when you get x approaches 0 from right side, this is 0, this is a 1. So it will be like this. When x approaches pi, it is a negative part, negative infinity. It's negative. So this is the graph over this region. And we also know that the cotangent is a periodic function with period pi, cotangent. So when you get one piece of a graph, you just repeat it or copy it over different quadrants. Here is a similar thing. Okay, so this is the graph. It's infinite. There are infinite curves, infinitely many curves. So it's a 3 pi over 2, and 2 pi, 5 pi over 2, 3 pi. It's a negative pi over 2, and what is negative pi, negative 3 pi over 2, negative 2 pi. Okay, so it's different from the tangent. Tangent, for one piece, it's an increasing function. Cotangent, for each piece, is a decreasing function. Okay, it's different. They are different. Okay. So from here, actually, you can get the similar list of the properties. The book does not give the list. Let's try to also collect the properties. We also make those 6 properties. First, the domain is the set of all real numbers except what? 0, pi, 2 pi, 3 pi, 4 pi, negative 2 pi, except k pi for integer k. Okay, whenever you have any integer multiple of k, you just exclude them. The range is from negative infinity to positive infinity. It can take whatever value. Okay, and 3, it is an odd function. Odd function. The graph is symmetric with respect to the origin. The graph is symmetric with respect to the origin. For it is periodic with period pi. Okay, 5, x-intercept Where is the x-intercept? Pi over 2, 3 pi over 2, 5 pi over 2. So whenever you have a k pi plus pi over 2, it's a x-intercept. This is actually the vertical asymptote of the tangent line. So you get x-intercept all the k pi plus pi over 2. All integers k. X-intercept. Y-intercept. No y-intercept because 0 is not in the domain. So there's no y-intercept. And vertical asymptote. It also has infinitely many vertical asymptotes. They are x equal to k pi for all integer. K equal to 0, it's this vertical asymptote. K is equal to 1, it's this one. K is equal to negative 1, it's the left part. Okay, that's a vertical asymptote. Right? So this is the similar list of the properties of a cotangent function. And if we do the transformation, it will be the similar. You sketch it and you compress or stretch along the horizontal or vertical direction, and then you do translation along the along the horizontal and the vertical directions. So we're not going to do that properties, but just keep this graph in mind. Okay, this is a cotangent. And let's try to get the graph of cosecant and the secant. Okay, cosecant. Cosecant is very close to cotangent because check here. They both have the denominator sin x. When sin x is 0, it is undefined, so you have the vertical asymptote. So technically, the cotangent and the cosecant have the same vertical asymptote. Okay, so we are going to one, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's it's a pi over 2. It's a pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, negative 5 pi over 2, negative 3 pi, negative 7 pi over 2, negative 4 pi. And vertical asymptote, it's at pi part, you have vertical asymptote, 2 pi, you have vertical asymptote, 3 pi, have vertical asymptote, and 4 pi, have vertical asymptote. Here, similar thing. And negative 2 pi, 3 pi, and 4 pi. Okay? And then let's check how do we sketch the graph of cosecant. It is the reciprocal of a sine. Let's first get the sine function. Okay, this is a sine function. Okay, that's a sine function. When you flip it, get the reciprocal. For example, 1 is still 1. If you get 1/2 here, if the value is equal to 1/2, what angle give you the value 1/2? Pi/6. Sine pi/6 is 1/2. If you get 1/2 here, the value will become 2. So it is flipped here. If you get 5 pi over 6, the value is also 2. 5 pi over 6, sine is 1/2, cosecant is 2. So when you flip a smaller number, it becomes bigger. So it looks like this. You flip the positive number, it will approach the positive infinity. And this part, if you flip a negative number, below the x-axis, negative, so you will get a negative infinity. So what you get? You will get this piece and this piece, the red one. And here the similar thing, you get red piece and left red piece. So each time you're going to flip this this curve up or flip it down. It depends on the region. But all the curves do not intersect the vertex asymptote. Remember that. So they are not connected. Over each two walls, you will have a piece either opening up or opening down. And here's this is a graph. The red curves are the graphs of y equal to cosecant of x. Y equal to cosecant of x. And also let's make this list of the basic properties. The properties of a cosecant of x. The domain. The domain of a cosecant of x is equal to the domain of a cotangent of x. The domain is the set of all real numbers except 0 pi, 2 pi, 3 pi, 4 pi, except k pi. K is integer. K is an integer. The range you see here, it is either less than -1. This is -1. This is +1. It's either less than -1 or greater than +1. It does not go between -1 and +1. So the range is from -infinity to -1, union from 1 to +infinity. Okay, so it meets the middle band. This is a domain range 3. It's an odd function. Remember that there are only 2 even functions, cosine and secant. Others 4 trig functions, sine, cosecant, tangent, cotangent, they are all odd functions. It is odd. The graph is symmetric with respect to the y-axis, the origin. So you have this curve, you rotate pi radian, it opens down, right? The graph is symmetric with respect to the origin. Okay, and 4, it is periodic with period 2 pi. Only tangent and cotangent has period pi. Other 4 trig functions have period 2 pi. 5, x-intercept. No, remember that it does not go to the middle band, so no. Y-intercept. No, it has no x-intercept, no y-intercept, because 0 is not in the domain, so no y-intercept. The value is either less than -1 or greater than +1, so it has no x-intercept. 6, vertical asymptote. Vertical asymptote is same thing, x equal to k pi for all integers k. For each integer k, you will get a vertical asymptote. Okay, so this is a graph of a cosecant. And now let's complete the graph with the final function, the secant function. Secant function, it has denominator cosine of x. Tangent function also has denominator cosine of x. So they share the same domain. It's a pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, and 7 pi over 2. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, negative 5 pi over 2, negative 3 pi, and negative 7 pi over 2. Because tangent of x has those vertical asymptote at each odd multiples of a pi over 2. So cosine function will also have the same vertical asymptote because they have tangent cosine. Remember tangent. Tangent secant function, they have the same denominator, cosine of x. Okay, and then let's sketch the graph. First, I'm going to sketch the graph of a cosine. And second, remember we're going to flip cosine. This reciprocal process is very close to the case when we sketch this graph, cosecant of x. Okay, so this is a graph of a secant of x. And we also list the properties of the secant of x. First, the domain is the set of all real numbers except what? Whenever I have a pi plus pi over 2, 0 plus pi over 2, pi plus pi over 2, 2 pi plus pi over 2, except k pi plus pi over 2 for each integer k. Okay, remember that those are the what? Check here, those are the zeros of a cotangent. When cotangent becomes 0, secant is undefined. Tangent is undefined. So you see those type of numbers a lot of times. Sometimes they provide the vertical asymptote. Sometimes they provide 0. Okay. 1, 2. The range. The range is identical to the range of a cosecant. It's from negative infinity to negative 1 because it also has two different pieces. One is below the x-axis, one is above x-axis. It's from negative infinity to negative 1 and from 1 to positive infinity. The graph misses the middle band. And this one is an even function. It is even. It is even. The graph is symmetric with respect to y-axis. Okay, even function. The graph is symmetric with respect to y-axis. And 4, it is periodic function. With period two pi. 5, x-intercept. No, there's no x-intercept because it misses the horizontal middle band. This between negative 1 and positive 1, it does not take the value. On y-intercept is 1. This point, this is y-intercept. And vertical asymptote. You see, we use this word again, those numbers again. X is equal to k pi plus pi over 2 for each integer k. Okay? So now you have the complete graphs of all 6 trigonometric functions. Just try to sketch them several times to understand the process. There's no easy way to memorize them. Just go through them with a exercise, and you will understand the graphs. Okay, so we finish this video, and you do your exercise. Send me email if you have a question. We will start a new video with the next section. Thank you.